Hello. Welcome to the walkthrough for our k-nearest neighbor machine learning model for classifying handwritten digits. This is mostly me just making sure that all of these materials still make sense, but hopefully the walkthrough will be clear for you also. So I'm going to go ahead and go to the URL for the GitHub page. Here it is. And I will go to clone the URL here. And then inside IntelliJ, you can say File, New, Project from Version Control. You can paste it in. I don't think I've cloned it already. I click Clone, and if all goes well, you should see it saying Clone down there. And I will open it in a new window, which is over on my other screen. Here it is. Great. So let's take a look and see what needs doing. So we've got a bunch of classes here. Let's open up Visual Classifier. So we see project JDK not defined. Hopefully you know how to fix this. Project structure, JDK 1.8, and I will set the language level to match language level 8. So 1.8, 8. I have a project compiler output folder already specified. All right. So if you give it a second, it will reparse. That looks okay. And let's see what happens when I run it before we've actually done anything. Okay, wonderful. So it's breaking, but that's to be expected. So let's scroll up to the top, and here it says, file not found exception, data mnist_train.csv file cannot be found. And like I said, that's sort of expected because if you look at the document, it says the first step is clone the project. The second step is you've got to download those data files. So let's go to the data URL. It says tinyurl.com/fhsmnist. So I will open that up. Here it is. Let's try that again. Here it is. All right, I'm going to pause it until it loads. Wow, so that took a surprisingly long time. I'm not sure what the deal is, but if yours is also taking a long time, hang in there. It will hopefully eventually work. So I will, let's see, I want to download this whole thing. So if you scroll down, you've got download. It will zip these two files and download them. And then in the instructions, it says that you're going to unzip them and put them in your data folder. And I'll show you what that looks like in just a second. Okay, so mine is downloaded. Here is my download folder. You can see zip file. Yours might not display the .zip extension here. On Macs, I believe it unzips automatically when you download it. It might not, but if you double click on it, it might. On a PC, you can right click. I have a 7-zip utility, which lets me extract. But the words like extract, unzip, all mean the same thing. Let's see, I think there's maybe another option down here. I don't really see another option, but anyway, there's definitely, you will see some way to unzip it. So let's do that. I'm going to extract to this folder. And if you go inside the folder, you will eventually find the two CSV files. So all you need to do is over here in IntelliJ, you've got your KNN MNIST framework. You've got a data folder. The data folder already contains some other data not related to handwritten digits. The only thing you need to do is select the CSV files, drag them straight over to the data folder. It will ask you if you want to move or copy them. Either is fine. And it wants to know if we want to add them to Git. I do not want to add them to Git. And there they are. So if you try and open them, you'll see what happens. So I double click. It's probably going to give me a message that says something like the file is too large, which is fine. But you see it just consists of some very long individual lines of numbers. And we'll talk more about what that is in a minute. Okay, the last setup step is going to the just KNN branch. We haven't really talked about branches in Git. Branches are just different parallel versions of your code base. So if you go to the Git menu, you should see branches. You are probably in the master branch, but you can just select the just KNN branch and say checkout. I've already checked it out, so it doesn't look that way for me. And let's try and run it one more time. See what happens now. All right, there we go. So clearly the visual classifier is doing something. I can click, and it seems to be loading images of individual digits. So let's learn what we're actually doing before we code anything. So we're going to make a handwritten digit classifier. The training set consists of a bunch of images of handwritten digits, along with the correct labels for what digit they really are. And if you remember, the general idea of training is you give it a whole bunch of correct examples. Your model will modify how it works internally so that it will be able to correctly predict future cases. And when we were looking at the perceptron, the way the model worked was we would have a linear combination of all of the individual values that were the input, and we were going to nudge the weights up or down so that the weights that combine the numerical inputs would lead to the correct classification. This is a totally different model. The k-nearest neighbor model does not work like a neural network does. But just to be clear and to remind you, each handwritten digit is a 28 by 28 pixel image. Each value is a grayscale, so 0 would be black, 255 would be white. And the image is turned into this 784 pixel vector, this input vector here. So that's what's on each single line of the CSV file, and that's what the input to your k-nearest neighbor model will be. So here's the algorithm. What you're going to do is you're going to loop over all the data points in the training data. The data points are not these numbers. These are the features of a particular data point. So remember, a data point is the training example that you have trained your classifier with. So you train your classifier with a whole bunch of data points. And the way we're going to classify an unknown example, a new input, is we're going to just loop over all of our saved training examples, and we're going to figure out which of them are the closest in space to the one that we are trying to classify. And because we know for our training examples what the right answers are, we know what the actual labels are. Like let's say k is 3, we'll find the 3 data points that are closest to this unknown one. We'll look and see what their labels are. If there's a majority vote where like one label is most common, that's going to be our prediction for the new unknown example. So if these were two-dimensional data points, we would use like the distance formula to find which point coordinates are closest to the input coordinates here. These are a higher dimensional space, so how do we figure out which is closest? Well, there's actually a lot of different ways of measuring closeness, but the one we'll use is a generalization of the distance formula. So here's the two-dimensional distance formula, where you just have the difference in x coordinates squared plus the difference in y coordinates squared, and you take the square root. Here it is in 3 dimensions. This picture is not super clear. And if we were doing this in class, I would actually project this on the board and sort of try and prove that this formula works to you, which you could do if you want. It's actually not so bad. But you can see that it's a pretty clean generalization. So you've got, if you have 2 points, here's Q, and then down here is supposed to be P, I think. You can find the difference between the x coordinates and square them. You can find the distance between the y coordinates and square them, and then the distance between the z coordinates and square them. Take the square root of all of that, and that's the 3-dimensional distance. So you can generalize that even further. For n dimensions, it's like each different dimension has its own coordinate. So you'll look at the difference in coordinate value between the points in the first dimension, and then the difference in the second dimension, and the difference in the third dimension, and the difference in the fourth dimension, and the difference in the fifth dimension, and so on, all the way down the list. And you look at all those differences and you square them all, you add them all together, and you take the square root. And that is the n-dimensional distance formula, which is a little bit slow to compute. So actually, if you end up running this and it runs super, super slowly, you might not take the square root. You might realize that the distance squared is just the sum of all these things squared, and maybe you can work with the distance squared instead of the distance, because that wouldn't require that you compute the square root. So I know you're probably eager to program. Let's dive back into this document real quick. I want to give you a quick overview of the classes that are there to support you. And then there are 3 different ways to test your classifier. One is visually, so it will actually display for you one of the training data examples, and then you can see what your classifier predicts that it should be. There's the interactive classifier where you can actually draw your own digit and your classifier will try and predict it. And then there's the test classifier, which doesn't have any visual output. It will just run through all the test data and show you how you performed on it. In all these cases, I'm trying to show you the sequence in which events happen. So for the test classifier, it will instantiate your classifier object. This is the one that you're going to be writing. Then it uses the data loader class to load the training data and the test data. Then it will add all the training data to your classifier. It will run your classifier's test method on the test data after it's been trained. And then it will display the ongoing tally of results. So you can sort of read through the sequence here. I think I've alluded to this already, but in the CSV file that we loaded a minute ago, each individual row is a new image, but it's the grayscale values of all 700 whatever pixels. The first column is the digit in the upper left-hand corner. The first column is the digit the image represents. So you see this is going to be the number 7. And then starting here with the second column, that's the actual data for the image. So, cool. Agreed. Okay, so data loader. Data loader is what actually reads the file, the CSV file, and returns a list of data point objects. And you can see a couple of methods here that are going to be helpful. Normalized line breaks, all that's happening there is different operating systems use a different character for going to the new line, like the \n. It's not always \n. So this is just a way of making sure that nothing's going to break regardless of the operating system you're running on. Read file is string. We've worked with that before. And then create data set is sort of the main one, where you give it a string and it will turn that into an actual list of data points. What is a data point? A data point represents a single image of a handwritten digit along with a label that's the correct answer. And so you can see the fields here. We've got data and label. And then you've got some getters and setters and the constructor. And then classifier is the one that you're writing. For classifier, you've got a constructor, you've got add training data, a couple of different overloaded forms of that. You've got classify, which is what actually makes the prediction, and you see some overloaded forms of that. So you could give it a D image, and it will make a prediction that's a string. You could give it a two-dimensional short array. Remember, short is what we use for grayscale values. We've got an n-dimensional distance formula here, which you'll have to program. And then test, you give it a whole list of points. It will run classify on each of these test points, check your classifier's prediction against the real answer, and kind of tell you how well you're doing. All right, so go ahead on the next page. Answer these check for understanding questions yourself. You can check the answers at the bottom of the page to make sure you're thinking about it clearly. And then go ahead and do the assignment. To implement classify, you're going to start by ignoring the k value. The k value is how many points do you get that are the closest to the uncategorized input point. And it's among those that you would take your majority vote of their labels to see which the real answer should be. Initially, let's just say k equals 1. So let's just find the single saved training value that is closest to the unknown input, and whatever its label is, let's make that our prediction for the new case. And then you can test how well that works using interactive classifier or visual classifier or test classifier. The bonus would actually be making it work for general k, which is actually fairly tricky, but I think you guys are probably up for it. And then again, you can test to see if it works. As an extension, there are different kinds of similarity measures besides just n-dimensional distance. And a really common one is called the cosine similarity measure. And it's computed this way using a dot product, if you know about that kind of thing. This is actually quite a different idea about similarity. It's not really based on distance. It's more based on direction. And if you know what dot products represent, you can think a little bit more about that. So yeah, I think that's it. Go ahead and try and code it up, tinker around with it a little bit. And I'll maybe have one more video. You might end up having questions, and there's one more video that I'll show you at the end that might answer some of your questions. Oh yes, let me say one last thing. So note about loading the data. So you might load the data this way. You've got your two-dimensional array of pixel values, and then you've got in the CSV file the row values. So So values are mostly zeros with some grayscale that represent white. So like this is what it actually looks like. What I did was I actually both eliminated grayscale and I made it just be black or white, and then I also like color reversed it. So if it was black in the CSV file, I've made it white because I thought that makes a better background. Otherwise, I've just made it black. So all the grayscale you see in the 7 here has just become black in the classifier there. But you could do it differently if you wanted to. And especially you should think, if you're able to, about whether or not my choice there is affecting the accuracy of the classifier at all. Okay, good luck.